I thought I was done, and then I decided I had forgotten to emphasize one last thing that really needs to be on this test as well, and that's the difference between a single x, which is distributed normally with some mean and some standard standard deviation, and an x bar, which is distributed normally with some mean and some standard error, sigma divided by the square root of n. This right here is what we use in hypothesis testing. It's what we use in confidence intervals. This is the central limit theorem, the CLT, central limit theorem. And what we need to know, the difference between an x with a mu and sigma and an x bar and a mu and a sigma divided by the square root of n, is that we have one observation here. So this one is one observation. Versus when we use the central limit theorem, we have multiple observations. So the central limit theorem is a sample of multiple observations. And you see that if I just consider my sample size being 1, this is the square root of 1, which is sigma, and that's it. That's what we have. So we would have to see that there's some sample size difference, and that is going to lead us to talking about x bars. Another key word when we talk about x bars is we say the average, right? That is another key. When you hear the word average, then you know you're going to be talking about a normal distribution, and that the standard error is what we're going to use for our sample or for our standard deviation, not just the standard deviation assumed in the population. And remember, we talked about this in great detail, and we saw some examples of it where the jitter minimizes, right? The more you have to go on, the less likely it is to be any different from your actual assumed population. So we saw that with our coin tossing example, and then we talked about that with a soda pop example, and we're just basically seeing that the central limit theorem, that's what it indicates using the sigma divided by the square root of n. So that I wanted to get out there too, because I actually typically will ask a question that makes sure that you understand the difference between just a single observation and a central limit theorem. And the way that you will have to do these are a probability problem. So it's the probability that x is greater than 2, or a probability that the average value is greater than 2. And for this one you would have to apply this, versus for this one you would have to apply this. And remember that we would have to standardize. We're going to find a z-score to then look that probability up. So x minus mu divided by sigma for this one, and for our other one, the x bar, our z is going to look like x bar minus the mu divided by our standard error, sigma divided by the square root of n. So that was the very last thing that, as I was kind of finishing these up, and went, oh, I forgot to talk about that. So that'll be the end of this little short video.